a lab procedure that is referred to as titration. This lab procedure's purpose is to determine the concentration of either an acid or a base. So we know that the material is an acid or base because we can test it with a litmus paper, but to know its specific concentration, its molarity, that is unknown. This lab procedure, it specifically uses the neutralization reaction. So when you react an acid with a base, in the neutralization process, you end up with water and salt. And so water is that neutral product because I like to write water's formula as HOH because the hydrogen from the acid, it teams up with the hydroxide from the base. So when you have equal number of moles of hydrogen reacting with equal number of moles of hydroxide, we have neutralization. So I could say in this, moles of hydrogen ion equal moles of the hydroxide. So we have a very simplified mathematical relationship that's listed on our table T. M times V, molarity multiplied by the volume equals molarity times the volume. So capital M is the molarity and the A stands for acid, where M and V on the opposite side are still molarity and volume, but the subscript of B stands for the base. So the way that we're going to do this in the lab is that our acidic solution has the unknown concentration. So in this mathematical relationship, MA, this is what we're solved for. So this is our unknown. We collect the data, and this is what we are going to solve for. That's the purpose of the lab. The things that we do know is the volume of the acid, okay? So we measure this, measure and record in the lab. So measure and record. So we will know the volume of the acid used. Same thing, volume of the base, measure and record. So we can track and figure out how much base we have used. So measure and record. And if we're trying to determine the molarity value of the acid, we must be using a base that has a known molarity. So this concentration is known. And in the lab, it is listed or written on its bottle. So read its bottle and record. Now, the way that we are going to determine the volume of the acid used and the volume of the base used is a piece of equipment called a burette. So a burette, the way it works is if you notice up near the top of the burette, you have your smaller numbers, and as you look down it, you see the numbers become larger. And in this process, it's because it uses a gravity feed, so we never pour like we would a graduated cylinder. The liquid, it flows out of the bottom. And we control the flow. So the way that we read a burette is we read it down this way. So that's the direction of how we read it. So wherever our meniscus of the solution or liquid inside the burette, okay, so let's see, this is where it's starting. This line is 10, so that means that this, I'm going to change my color here, this next little line means 10.1, and then 10.2, to the slightly longer line we have 10.5, the line just before the 11 mark is 10.9. So my meniscus has passed 10.0, 10.1, but it has not reached 10.2. So I read it at the bottom of this meniscus. So my starting volume, like volume 1, is 10.1, but it hasn't quite reached the 0.2 line, so I would estimate a 9 where it's almost there. So my initial volume is 10.19 milliliters. And then I open what we refer to as the stopcock, the lever, and when you put it in the open position, the liquid will start to flow out, and you will visually see the meniscus of the solution. It will start to flow out. So the meniscus, where it starts with the flow, it's moving and dropping down, right? And then when we turn it off, and wherever the meniscus ends, so here's the resting spot of the meniscus. So it flowed past the 11, but didn't quite reach the 12. So I know that my ending volume, V2, from where the liquid started to where it ends, went past 11, and I know this slightly longer line is 11.5, 11.6, and it has not quite reached the 11.7 yet. So this is 11.7, this is 11.6. So the meniscus flowed past 11.6, but it has not reached 11.7 yet. So it's a little bit more than 11.6. It seems to be about halfway, so I'm going to say 11.65 milliliters. So my meniscus started at 10.19, and it ended at 11.15. So the volume used, so I'm going to do this. So the volume that I actually used is equal to the V2, where the meniscus ended, minus the V1. So my volume I used in this lab was 11.65 minus 10.19. And so the difference between those is the amount of acid or base, or whatever I had in there, whatever I allowed to flow out and collect. So calculate this. 11.65 minus 10.19. And so the volume I used was 1.46 milliliters.